Hello children, how are you? Well, in the last module we had been learning about the physical chemical properties of metals and its uses in our day-to-day life. But we were left behind with the displacement reaction of the metals and it's the reactivity series. So here in this module we would be dealing with the reactivity series of the metals and the chemical and physical properties of non-metals and the uses of non-metals in our day-to-day life. So let us not waste much of our time and start learning it one by one.
In our other video, you will have seen how 8 metals were ranked into an order of chemical reactivity, known as the Reactivity Series. In this video, you will see how this list can help us predict if a chemical reaction will proceed and how to name the products. Before we begin, we need to modify the list to include the non-metal carbon, which has a known chemical reactivity relative to the metals shown. A displacement reaction is simply when one element pushes out or displaces another from a chemical compound. For example, if a mixture of grey zinc powder and black copper oxide powder are mixed and then heated strongly, causing the reaction to start, we see a violent chemical change, lots of heat and light, making red copper powder and white zinc oxide. Zinc plus copper oxide equals zinc oxide plus copper. Look at where the metals zinc and copper are in the reactivity series. Zinc is above copper and so is the more reactive metal of the two. So zinc, being a more reactive metal, can push out or displace copper from its compound. What if we tried the reverse reaction? Copper plus zinc oxide equals... This reaction will not work, as copper is not reactive enough to displace zinc from its compound. This shows how we can use the reactivity series to predict if a reaction will go, and if it does, then we can name the product by switching the names of the metals around. Try these examples. Decide whether the reaction will work, and if so, name the products. Pause the video while you work this out. How did you do? For example, if you put iron powder in a blue copper sulfate solution, quite quickly you observe a red powder appear, the copper, and a pale green solution of iron sulfate forms. We added the element carbon to the reactivity series at the start of this video, so now let's use it. Decide which of these reactions will go and name the products. Here's a hint. Carbon oxide is carbon dioxide. Pause the video and have a think. Were you right? Look at this table, which shows when each metal in this reactivity series was discovered. Notice how metals less reactive than carbon were discovered a long time ago. This is because to isolate these metals from their compounds found in ores, ancient people used charcoal, almost pure carbon, in a fire or furnace to displace these low reactivity metals. This displacement reaction is known as smelting. Very reactive metals required quite different chemistry to be isolated and needed the discovery of current electricity before this could happen. So to recap, you don't need to memorize the list of metals in this series, but you should be able to use it to predict what change, if any, you would expect if a metal is reacted with another metal compound.
Non-metals: carbon, sulfur, iodine, oxygen, hydrogen, etc. are non-metals. The non-metals are either solids or gases, except bromine, which is a liquid. Physical properties: all metals except mercury exist as solids at room temperature.
Gallium and cesium have very low melting points.
These two metals will melt if you keep them on your palm. Iodine is a non-metal, but it is lustrous. Carbon is a non-metal that can exist in different allotropy. Diamond is the allotrope of carbon. It is the hardest natural substance and has a very high melting and boiling point. Graphite is another allotrope of carbon. It is a good conductor of electricity. Alkali metals are so soft that they can be cut with a knife. They have low densities and low melting points. Non-metals produce acidic oxides when dissolved in water, and metals gives rise to basic oxides.
Chemical properties of nonmetals. Nonmetals gain electrons to form negatively charged ions. Thus, they are called electronegative elements. Let us discuss some examples of chemical reactions of nonmetals. Reactions of nonmetals. Reactions of nonmetals with oxygen. Nonmetals react with oxygen to form acidic oxides or neutral oxides. Carbon is a nonmetal. It reacts with oxygen and undergoes complete combustion to form the acidic oxide carbon dioxide. During the incomplete combustion of carbon, the neutral oxide carbon monoxide is formed. Sulfur is also a nonmetal. It reacts with oxygen to form an acidic oxide called sulfur dioxide. Reaction of nonmetals with water. Generally, nonmetals do not react with water except halogens. For example, chlorine dissolves in water to form hypochlorous acid and hydrochloric acid. Hydrogen. Nonmetals react with hydrogen under certain conditions like proper temperature, pressure, use of catalyst, etc. For example, nitrogen reacts with hydrogen in the presence of iron catalyst to form ammonia. Sulfur reacts with hydrogen to form hydrogen sulfide.
Now let us discuss uses of few nonmetals. Carbon is a nonmetal. Diamond and graphite are two forms of carbon that are found naturally. Diamond is a well-known jewelry material. It is also the hardest naturally matter and is used in cutting glass and in grinders. Pencil leads are made from graphite. Sulfur is used in the manufacturing of gunpowder and vulcanization of rubber. In vulcanization, rubber is heated with sulfur and other materials. After this process, elasticity, resilience, tensile strength, viscosity, hardness and weather resistance of rubber increases. Phosphorus is used in matches, rat poison, etc. Matchsticks contain phosphorus and chlorate which, on friction, acts like a explosive and help wooden stick to burn. Nitrogen is base material of proteins which are used by living beings for growth. In plants, ammonia is good source of nitrogen. Ammonia is made from nitrogen nonmetal. Chlorine is helpful in killing dangerous microbes and thus it is used as a bleaching agent and in sterilizing water. Sterilizing is the process in which harmful microbes are removed from something. Hydrogen is used as a rocket fuel and hydrogen flame is used for cutting and welding purposes, as well as a reducing agent. Reduction is the process by which pure metals are obtained in a chemical reaction.